In this example, we're going to practice the quotient rule and finding equation of tangent line. So we are given that f of x is e to the x over 2x plus e to the x. And we are asked to find the derivative as part A. And then we're going to use that information to find the equation of the tangent line when x equals 0. So I'll just write this on the side. So for part A, we need to find the derivative. So f prime of x, using the quotient rule, we have the derivative of the top times the bottom minus the top, and then times the derivative of the bottom. And the derivative of the bottom will be 2 plus e to the x. And then we have all over the bottom squared. So without any simplification, that is what the derivative looks like. Since we're going to do some things with it, it might help us to simplify it a little bit. But right now, I'm just going to leave it as is. For part B, we're asked to find the equation of the tangent line when x equals 0. So what we're going to use the fact that m, our slope of our tangent line, is going to be f prime of 0. So being very careful, we have e to the 0. I'm going to write everything down. And then we're going to have 0 plus e to the 0 minus e to the 0, 2 plus e to the 0, all over 0 plus e to the 0 quantity squared. And remember, e to the 0 equals 1 to help us. Again, the better you are with that kind of arithmetic, you wouldn't have necessarily need to write all this. So this simplifies to 1 plus, or 1 minus, this is 1 times 3, all over 1 squared. So we have negative 3. Oops, sorry, not negative 3. Negative 2. Okay. So that's our slope. We need a point on the line. And they didn't tell us what the point was, but they did tell us we care about it at x equals 0. So the point we're going to use is at 0 and f of 0, which is going to be, if we plug in 0 here, we get e to the 0 over 0 plus e to the 0. So we have 1. And the good news is, this is our B. That makes our lives a lot easier. That is our y-intercept on the line. So our final answer for the tangent line is going to be y equals negative 2x plus 1.